Transform your business with Microsoft Azure, the one-stop shop for everything cloud and AI. With Azure Migrate and Modernize, move your existing workloads to Azure with ease. With Azure Innovate, build new solutions with focused and deep engagement. Their core offerings provide comprehensive resources, expert assistance, and cost optimization tools. Accelerate your cloud journey and stay ahead of the competition with Microsoft Azure. Visit aka.ms/Azure Hero Offerings to learn more. That's aka.ms/Azure Hero Offerings to learn more.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. Before we get into this week's topic, I just wanted to share a quick behind-the-scenes story. We usually record the interview segments anywhere from a week to a few weeks ahead of time, and we usually have a decent backlog of shows, so we always have a show ready to go for you every Wednesday. Things have been a little hectic around here at the massive studio, and we got a little behind in our recordings, and then we had a last-second cancellation, and before you know it, it's Tuesday, and we don't have a show this week. So I sent out a distress signal to some folks, and I have to say a special thank you to our guest this week, Shreya from Guardrails AI. She jumped on with a couple of hours notice and even powered through being a bit under the weather. So a special thank you this week to her. And we're going to jump right into the interview, and we're going to do that right after this break.
Are you looking to stay ahead of the curve in the latest trends in enterprise tech? Look no further than the Breaking Analysis podcast with Dave Vellante. This data-driven program dives into the most important topics facing the enterprise tech industry today. With a data-first approach that leverages ETR's renowned surveys of IT decision-makers and insight from the CUBE community, Breaking Analysis delivers in-depth research on the most important topics facing technologists and IT buyers. Whether you're a business leader, an IT professional, investor, or just an avid follower of the industry, this podcast is a must-listen. Just search Breaking Analysis Podcast wherever you get your podcast and tune in today to stay ahead of the game in enterprise tech.
And we're back, and we have a really great topic for this weekend. Something actually I personally have been wanting to dig into for a little bit. But before we do, I want to do quick introduction and get that out of the way. We have a fantastic guest. So we have Shreya, CEO and co-founder at Guardrails AI. How are you doing, Shreya?
I'm doing great. I'm so excited to be here.
Absolutely. So before we dig into today's topic, why don't you give everyone just a little bit about your background, please?
Yeah, absolutely. So my background is almost all in machine learning. I've worked for the past decade in machine learning. Before starting Guardrails, most recently I was founding engineer and led the machine learning infrastructure team. So training really large models on small compute sizes for an MLOps startup. Before that, I worked in the self-driving industry for a number of years. First at a startup, training a lot of the computer vision models and perception models that were running on the car that were, cars that were driving in different cities. And that company was acquired by Apple. So I worked on autonomous systems problems at Apple. And then before that, I was doing a lot of research in classical AI and computer vision, et cetera. So have spent pretty much my whole life working in machine learning. And then when the generative AI adoption, outside of generative AI was being adopted outside of ML practitioners and into this larger application ecosystem, really started thinking about what would it take to use AI just as any other piece of infrastructure. And, Guardrails AI really came as an exploration of that. Yeah.
That's fantastic. And that's a great segue into our topic for today, because we've talked about AI many times on the podcast, but this concept of hallucinations or this concept of data quality or quality of the answers and validation, we see many kind of instances of, unfortunately, both interesting things and then sometimes some pretty bad things that can happen with at times. And so our topic today is validation and accuracy of AI and providing guardrails around that. So maybe let's start with a little bit of the why, Shreya. Why do we need guardrails for LLMs and generative AI today?
Yeah, I think that's such a great question and a question I spend a lot of my own time thinking about. So I think if you look at how AI models are being used today and what these models can do. I think most of us have, played around with ChatGPT at this point. So if you use ChatGPT, then, you kind of know that you can use the same underlying AI model for, writing code or helping you write a SQL query, or you can get it to maybe write a poem about the Super Bowl. You can, use it maybe as a companion, or use it, for mental health and talking through issues, etc. So it's the same model that can do like everything under the sun, right? But if you then look at like when people adopt AI into their stack, or when they're building applications on top of AI, are they looking for that, that full set of capabilities, or are they looking for, a much more finite set of capabilities with a much, much higher degree of like reliability and precision? And more often than not, most commonly, it's the latter, right? So if you think about a bank trying to adopt generative AI, does the bank want their AI to write a poem about the Super Bowl? They probably don't. They just wanted to talk about, hey, my transaction didn't go through. What could be wrong here? And then maybe, the AI to like help them with the customer support queries, etc. So you need a lot of constraints to make any generative AI that you're adopting into your stack work as you want it to, within the parameters of what's acceptable to you, without introducing, a whole lot of risk for you. And risk and managing risk that comes with AI is essentially the key problem that, is still unsolved, and then we're really excited about solving. And so that's where the need for guardrails really comes from. So how do I take, this extremely powerful technology that really passed the Turing test for the first time in history, and how do I constrain it so that it works as a really, really good employee of mine, or a really, really excellent assistant would?
Yeah, that's fantastic. And I'll add this, from folks I talk to, I would say two things: risk and unpredictability are kind of the top barriers to entry for Gen AI today. Where and how do you control the outputs from the LLMs today, right? Like, and by the way, too, control maybe is a bad word. Maybe it's validate, right? This feels like a problem every organization out there that is looking at Gen AI or LLMs. It's a similar problem everywhere, right? Because by its very nature, the LLMs generate different outputs, even if you give the same prompt over, multiple times, or even over time, because the data sets change, or just the LLM gives a different answer. The answers are never guaranteed to be the same. And so I kind of see, and help me if this is a good way to think about this, I see a few different ways to like add this validation and guardrails into the app workflow. Like there's the prompt, and I think like there's been instances where folks have taken like ChatGPT, the API tokens, and it's like 1,500 or 2,000 characters of all the guardrails it tries to put around answers that are already put into every prompt right behind the scenes. Or it could be fine tuning in RAG, or it could be at the API level. But is that a good way to think about this, or is there a better way? Is there a better way to kind of wrap this environment in? Is this inline? Is this from the output? How do you go about doing this validation?
Yeah. I think it's such a great problem. Such a great question. And I think the problem, we're already starting to see some effects of the problem taking place. So this podcast is going out, I think, on February 20th, 21st, depending on, which time zone you're in. So according to that time, just last week, there was this really publicized news of an Air Canada chatbot that hallucinated some information about the, I'm going off of memory here, but like something about the return policy on some flight tickets that was completely hallucinated. And a customer, took actions based on what the chatbot said the return policy was, and the flight the flight company refused to respect it later on. And so this really resulted in the chatbot not being factual, not respecting what's ground truth for the company, and then that had consequences for the company, right? So they were fined by I think the highest court in some court in Canada, etc. So I think the problem ends up being pretty endemic, and as this technology gets more and more adopted and more part of our workflows, I think having a very, very robust system of validation and verification becomes pretty essential. So where we add this layer of verification is kind of on the systems level. We are in your critical path post-production inline. So essentially, you can use whatever model you want. Maybe that's a fine-tuned model. Maybe that's, an off-the-shelf OpenAI model. You can find the best possible prompt that you can, for that model. But at the end of the day, when you're running the system in production, there's like constant, live monitoring of the types of risks that you care about that you need to do. And that is where we come in handy. So essentially, we surround your application with a safety layer. And anytime the prompt is leaving your application or your VPC and going to a foundation model, we have what we call an input guard. And that input guard, looks at like specific types of risks. Once that prompt is sanitized for those types of risks, maybe those risks are around like PII leakage or data, private data leakage. Maybe those risks are around the type of conversation that the prompt represents. So, like maybe you're building a customer support chatbot, you only want to talk about, the features of the application that you have customer support on. You don't want to talk about, the 2024 general election or maybe once again, the Super Bowl. So you want to make sure that, you're constraining it and not letting it go off topic. So that would be another risk that we can catch in the input guard level. We can catch for like jailbreaking attempts, etc. So there's an input guard filtration that happens. And then once that prompt is looked at and sanitized and made sure that it doesn't violate any expectations, you send that prompt to the LLM and you end up getting that response back. Now that response first goes through an output guard before it is sent over to the application. So that output guard can look at if like false PII that is generated, that is actually interestingly happened with me a lot of times in the applications that I use. It can look for any compliance violations, so factuality errors, or maybe you're a financial institution and you don't want to generate any financial advice. So it can look for those types of, risks. It can look for mentions of competitors that, if you're building a customer facing application, you don't want to mention your competitors or promote your competitors. So you can check for all of those types of risks on the output guard before you send that output out. So that's kind of like the architecturally where we sit. And this was a very strategic decision on our part. Like we were like a lot of the inspiration for Guardrails really comes from my background in self-driving and how validation and verification is done in self-driving. And I thought very deeply about, what is the right way, what is the most impactful way for an organization or a team that is building an AI application to add guardrails to their system. And, this was by far the highest impact, architecture to add that safety layer. Like, for example, like working on the prompt level, just adding a lot of, don't do this, don't do that kind of assertions in the prompt or model fine tuning. None of those are, I guess, none of those are guarantees in some sense, right? Like prompts are instructions, they don't guarantee specific output. At the same time, model fine tuning, you're providing it data, and it is really effective. You end up more likely to duplicate the behaviors that you'd seen in the data that you use for fine tuning. But once again, you get out of distribution use cases, etc., and you want to be able to dynamically catch them. So that's why we work in the critical path. Yeah.
And I actually just thought of this as you were saying this about your background and going from autonomous driving and machine learning to Gen AI and LLMs. And this is more just a personal question. How much does it bother you? I guess with autonomous driving, it's very black and white, very binary. It's either a wrong answer or a right answer kind of thing, right? And then generative AI tends to just kind of does whatever it wants. And so is this more of like the background of like, hey, the true science-y portion of your brain going, hey, I can't understand why these things aren't providing the same things, and it needs to be more consistent?
I think that's an interesting comparison. You'd be surprised with like self-driving, how different how vast the space of decisions is, if that makes sense,
Mm-hmm.
So with the same input, with the same kind of state of the world, you can, choose to maybe change your steering angle by like some small delta and it won't make a difference. Or you can change it by, a very large delta and maybe change lanes, and that won't have a difference in, where you're going or your output. But if you change it like somewhere between a tiny delta so that you stay in your lane and a very large delta so that you, change lanes, but you're somewhere in the middle where you're overlapping.
Sure.
Like that's what the problem is, right? So even in self-driving, like depending on the objective that you're optimizing for, you do end up having a whole like vast set of options for how to get there. And some of those options can be very different from each other and be correct. And some of those options can be more similar to like other correct options and yet be incorrect. So that parallel, works really well for Gen AI. Because if you think about like summarization, right, as this classic example, and one of the things that LLMs are actually pretty good at, and they're weirdly good enough where all of the previous, like, I feel weird calling it that, but old school machine learning, like I guess the foundation model era of machine learning. So in that era, summarization, this classic machine learning problem, and we had all of these metrics for what a correct, like how to evaluate the quality of the summary, right? And it was based on, these golden data sets, etc. And if you look at the summaries that are generated by, foundation models or LLMs, and those summaries, will look very, very different from the golden data sets you have, very different from each other, in fact, as well. But a human will look at the summaries and be like, yeah, both of these summaries are equally as good, or they hit, the key points that I care about, etc. So I think that parallel works really well, with self-driving as well. So I think the interesting technical challenge here is when you can have like multiple correct answers that are all really different from each other, or you can have like two similar answers where one is correct, one is incorrect. How do you encode programmatically what correctness means for you, right? Like if you can't like directly compare the text for, a golden summary versus a LLM generated summary for correctness, what does a correct summary mean to you, and how do you encode that criteria and like run it at runtime to make sure that it works as expected? And that's kind of like the key like I guess a thesis behind how Guardrails is implemented, which is that we aren't publishing metrics, etc. We are encoding like all different sorts of correctness criteria across a host of use cases, host of applications, etc. So we encode that correctness criteria and then run it at runtime and tell you, like, according to your correctness criteria, how effective are these LLM inputs and outputs.
Okay. That's super helpful, Shreya. Let me ask maybe a follow on that, because we kind of dipped our toe a little bit into the whole idea of I'll use the term humans in the loop, right? When we were talking about the validation earlier on, we really were talking about the inferencing stage, or the running stage, if you will, versus, say, the fine-tuning or training stage of a lot of these models. And what I've seen in practice is a lot of the really large models, a lot of times get trained with humans in the loop of like, here's a bunch of examples, and this is correct or this is incorrect, and kind of doing that over and over and over. And so just thinking ahead, is this validation, could this apply in the training and fine-tuning stage, or is it really just something that's for inferencing and running?
Yeah, I think that's an excellent question. I think you definitely can take a lot of the validation techniques that you use at runtime and then use it for model fine tuning. Essentially like RL, like the equivalent would be like RL, AIF, like instead of RLHF, etc. Which is learning from human feedback or AI feedback, and you can use the validators as feedback. I think the interesting thing there, however, is like for any model training, you typically need I think data is basically the key blocker, which is, it's such a cliche, which is, all machine learning problems are basically data problems, which might not be true anymore in the Gen AI world, but definitely for the longest time in machine learning, that was definitely true. So I think you kind of like do need high quality data regardless to be able to train these models, not to mention, the high degree of like compute, et cetera, that you typically end up needing. So for example, like we work with organizations where when state-of-the-art open source models are released, they are extremely excited, and eventually they do want to train their own models. But first, they want to prove out, how valuable or impactful are the use cases that they're building with Gen AI, right? And so before you make this massive investment in like data for fine tuning or like infrastructure for fine tuning, like how can you kind of short circuit some of the MVP ML modeling efforts so that you can get like an ROI, and then you can like fine tune models based on the correctness criteria that is important for you. So that's kind of the path that we end up seeing a lot.
Fantastic. And I know we talked about it a little bit already, but I just want to kind of call it out specifically. What are some of the most common early use cases or practical examples you're seeing with this validation in Guardrails? Is it PII? Is it ethics? Is it, something goes, LLM just goes completely off topic or out of scope? What are the top of mind hot button issues, if you will?
Yeah. Excellent question. I think a lot of the current adoption stems from use cases. So I think it's kind of like this backwards link from, what are the use cases that most people are implementing? And then, based on the use cases, like what are the validation techniques that end up being important? And by far, like by a margin, the biggest use cases that are anywhere close to going into production or maybe in production already are customer support chatbots, So it's very, I guess, it's the first order of business that people end up implementing. And then for chatbots, a key concern is like factuality. I think factuality and hallucinations are something across the board, no matter, if you're a customer support chatbot or, maybe just a help center chatbot or you're in let's say like a customer facing application in a bank versus your like a FMCG, etc. You always care about factuality, you always care about hallucinations, so that ends up being like really impactful typically. And then depending on the type of application you have, other concerns kind of come into play. So if you're customer facing, there's a lot around like tone and etiquette. So I want to follow, like I should have this specific tone. There's a lot around structure of responses. So my responses should always open with, an introduction, and then maybe like reiterating the problem that my user has back to them. And then, then kind of like suggesting responses and then checking with them if that like helps answer their question, etc. So the structure of the response should be consistent with, what the company's like actual customer support agents are trained to provide. So there's a lot around that. There's a lot around like regulation. So for specific domains, so if you're financial services, for example, you typically care about, your chatbot doesn't accidentally give out financial advice, which would land you in a host of trouble. So there's, validation around that. That's pretty impactful. And then, again, like maybe some finer things like, don't mention any competitors of mine or maybe any other vendors. So if I'm a bank building a chatbot on top of, foundation model company, let's say OpenAI, then I don't want my chatbot to accidentally say, I'm a chatbot developed by OpenAI. I want to be like, I want the chatbot to talk as if they're a representative of the bank. So I think there's a lot of like validation techniques around that. PII also, of course, yeah.
Yeah, of course. Absolutely. Well, and let's talk about Guardrails AI specifically for just a bit. You have an open source marketplace, Guardrails Hub. Did I get that correct?
Yeah,
okay,
that's right.
Okay. And I just want and tell everyone a little bit about the offering, and then tell everyone a little bit about the concept of validators and how you could stitch them together for a solution.
Yeah, absolutely. So Guardrails Hub really came through because of a lot of the people that we were talking to. There's a bunch of problems that we kind of saw, which meant that the hub could be really useful and really impactful for that population. So for example, we would talk to multiple like financial institutions that were building an application, and they would typically have similar sets of constraints that they wanted these models to follow. And because this is a pretty new like area of tech generally, so there'd be this concern about like, okay, is what I'm doing the right thing? Is this what state of the art is this what other players in the market are kind of doing? So kind of this gap about like, okay, I'm kind of implementing this, but I'm not really sure if this is the right thing to do. And so they'd end up kind of reinventing the wheel to some degree and re-implementing a lot of the solutions. Like we kind of saw the same use cases and the same kinds of solutions pop up over and over again. I think that was a key concern. And then the other key concern was essentially around the, I guess, the reusability of a lot of the validators. So being able to reuse validators is key. But typically, even with the example of financial advice for organization A is very different from financial advice for organization B. And how do you make sure that, you're using something that's off the shelf, so maybe it doesn't capture what financial advice means for you, right? So how do you make sure that you're able to kind of capture, get help with state-of-the-art solutions out there, but really customize them to your own needs? And the hub really, really helps with that. So the intention was a central repository. It's all open source. So I think I guess technically it wouldn't be a marketplace because we're not, you just open source, download it and start using it. But the idea is that you can look at a lot of the guardrails that we have, a lot of, the things that they're good for and bad for, make an informed decision about if this works for you. For a lot of them, you can get started with using them out of the box. But for others, you can see what they're good at, what the state of what is the performance that they can kind of achieve, and then you can really customize them and fine tune them for your own use cases. So the hub kind of came, was the result of us seeing that problem.
Fantastic. And I think actually that's a perfect summary of the topic for today. So Shreya, one last kind of question. If anybody out there is interested in this concept, wants more information, wants to reach out to you, what is the best way that they could do that?
Yeah. So we have a lot of avenues because we're open source. Our GitHub is a great place to reach out to us. So go to GitHub /guardrails-AI, and then or if you just Google search Guardrails space AI or AI Guardrails, I think it's the top result or something. So our GitHub, we have a Discord where we're extremely responsive, so you can kind of reach out to us. You can follow us on LinkedIn or on Twitter. Again, we're pretty active there, and we keep sharing the latest and greatest in AI reliability in that space. So it's Guardrails AI in both of those places, or you can reach out to me directly as well, either on LinkedIn or on Twitter. I am Shreya R, SHREYAR on Twitter. Yeah.
Fantastic. Well, thank you so much for your time today. And for everyone out there, thank you once again for listening. And if you have a moment, please tell a friend. Please leave us a review wherever you download your podcasts. I'm going to wrap for this week. Thank you again for your time, and we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.